Let's take this work squaring with algebraic notation to the next level. Now, sometimes we could just be given the algebraic notation of a binomial here. And instead of taking a square and labeling it with the letters, what you could do is plug in numbers. Now you can plug in any number you want. You could get really big. So you could say, for example, A equals, for this example, I'll do 7. Or no, A actually is 7. Here, we'll say, we'll say 25. We'll get a big number. A equals 25 and B equals, B equals, let's say 14. So if A equals 25 and B equals 14, kind of like I would with a formula, I would just plug in the numbers where the letters are. So instead of A squared, I would write 25 squared plus 2, and I can use parentheses here to help me. 2 parentheses 25 times, well, A is 25 and B times 14 plus B squared, which is 14 squared. So then I would do my math just like I would do previously. So I would do some side multiplication, and I might see that 25 times 25. I would do my side multiplication, and I would see that that's 625 plus 2 parentheses. Remember, just like the order of operations, we solve what's in parentheses first. 25 times 14, which is 350 plus 14 squared. So what is 14 times 14? 196. And then I keep solving like order of operations. So 625 plus 2 times 350, which is 700, plus 196. And then I would add my numbers up, and I can do this horizontally by starting with my units. 5 plus 0 is 5, plus 6 is 11. Carry the 1. 1 plus 2 is 3, plus 0 is 3, plus 9 is 12. Carry the 1. 1 plus 6 is 7, plus 7 is 14, plus 1 is 15. So my answer is 1,521. Now, in order to check my work, I could use a calculator, or I could also add up, well, what's A plus B? 25 plus 14. 5 plus 4 is 9. 2 plus 1 is 3. And then I would calculate what 39 squared is, which is equal to 39 times 39. I would then do my math, long multiplication, lattice multiplication, really up to you, however you choose to do it. But if you multiply 39 times 39, you end up with 1,521. And that's the same thing I got right here. So it checks.